Good morning. We are now going to start solution of exercise. Question 1. Copper can be extracted by hydrometallurgy but not zinc. Explain. And the answer is the reduction potential of zinc and iron are lower than that of copper. In hydrometallurgy, zinc and iron can be used to displace copper from their solution. Fe plus Cu plus 2 gives Fe plus 2 plus Cu. But to displace zinc, more reactive metals means metals having lower reduction potentials than zinc, such as magnesium, calcium, potassium, etc., are required. But all these metals react with water with the evolution of hydrogen gas. As a result, these metals cannot be used in hydrometallurgy to extract zinc. Hence, copper can be extracted by hydrometallurgy but not zinc. Now, question is, what is the role of depressant in froth flotation process? In the froth flotation process, the role of the depressants is to separate two sulfide by selectively preventing one ore from forming froth. For example, the separate two sulfide ores, zinc S and PbS, NaCN is used as the depressant, which selectively allows PbS to come with froth but prevents zinc S from coming to froth. This happens because NaCN reacts with ZnS to form Na zinc CN4 plus Na2S. Question 6.3. Why is the extraction of copper from pyrites more difficult than that from its oxide ore through reduction? And the answer is the Gibbs free energy of formation delta G of Cu2S is less than that of H2S and CS2. Therefore, H2 and C cannot reduce Cu2S to Cu. On the other hand, the Gibbs free energy of formation of Cu2O is greater than that of CO. Hence, carbon C can reduce Cu2O to Cu. Hence, the extraction of copper from its pyrite is difficult than from its oxide or through reduction. Question number 6.4. Explain zone refining and column chromatography. Answer of zone refining. Zone refining method is based on the principle that impurities are more soluble in molten state of metal. In the process of zone refining, a circular mobile heater is fixed at one end of a rod of impure metal. As the heater moves, the molten zone of the rod also moves. As a result, Pure metal crystallizes out of the milk and the impurities pass into the adjacent molten zone. This process is repeated several times, which leads to segregation of impurities at one end of the rod. Then the end with the impurities is cut off. Silicon, boron, gallium, indium, etc. can be purified by this process. Now, column chromatography. Column chromatography is a technique used to separate different components of a mixture. It is very useful technique used for the purification of elements available in minute quantities. It is also used to remove the impurities that are not very different in chemical properties from the element to be purified. Chromatography is based on principle that different components of a mixture are differently absorbed on absorbent. In chromatography, there are two phases, mobile phase and stationary phase. The stationary phase is immobile and immiscible. Al2O3 column is usually used as the stationary phase in column chromatography. The mobile phase may be a gas, liquid, or fluid in which the sample extract is dissolved. Then the mobile phase is forced to move through the stationary phase. The component that is more strongly absorbed on the column takes a longer time. Than the component that is weakly absorbed. The absorbed components are then removed using a suitable solvent. Now, question number 6.5. Out of C and CO, which is a better reducing agent at 673 Kelvin? Answer of 6.5. At 673 Kelvin, the value of delta G of CO2 is less than that of delta G CO. Therefore, CO can be, means carbon monoxide can be reduced more easily to CO2 than carbon to CO. Hence, CO is a better reducing agent than C at 673 Kelvin. Question number 6. Name the common elements present in the anode mud in electrolytic refining of copper, and why are they so present? And the answer is, in electrolytic refining of copper, the common elements present in anode mud are selenium, tellurium, silver, gold, platinum, and antimony. These elements are very less reactive and are not affected during the purification process. Hence, they settle down below the anode as anode mud. Now, question number 6.7. Write down the reactions taking place in different zones in blast furnace during the extraction of iron? This answer is already have been explained, but here the answer: during the extraction of iron, the reduction of iron oxide takes place in the blast furnace. In this process, hot air is blown from the bottom of the furnace and the coke is burnt to raise the temperature up to 2200 Kelvin in the lower portion of the blast furnace. The temperature is lower in the upper part. It is the lower part where the reduction of iron oxide takes place. The reactions taking place in the lower temperature at range 500 to 800 Kelvin in the blast furnace, and the reaction taking place in the higher temperature range 900 to 1500 Kelvin in the blast are C plus CO2 gives CO, twice CO. And last, we can obtain calcium silicate from CaO and silicon oxide SiO2. Now, question 6.8. Write chemical reaction taking place in the extraction of zinc from zinc blende. And the answer is the different steps involved in the extraction of zinc from zinc blende means Zn are given in the concentration of ore. First, the gangue from zinc blende is removed by the fourth flotation method, and then conversion to oxide is carried out, means roasting method is carried out. In this method, sulfide ore is converted into oxide by the process of roasting. In this process, Zn is heated in a regular supply of air in a furnace at a temperature which is below the melting point of zinc. Third method is extraction of zinc from zinc oxide, and it is reduction. Zinc is extracted from zinc oxide by the process of reduction. The reduction of zinc oxide is carried out by a mixing with powdered coke and then heating it at 673 Kelvin. Now, fourth method is electrolytic refining. Zinc can be refined by the process of electrolytic refining. In this process, impure zinc is made the anode while a pure copper strip is made the cathode. The electrolyte used is an acidified solution of zinc sulfate, ZnSO4. Electrolysis results in the transfer of zinc impure from the anode to the cathode. Next question is question 6.9. State the role of silica in the metallurgy of copper. During the roasting of pyrite ore, a mixture of FeO and Cu2O is obtained. The role of silica in the metallurgy of copper is to remove the iron oxide obtained during the process of roasting as slag. If the sulfide ore of copper contains iron, then silica means SiO2 is added as flux before roasting. Then FeO combines with silica to form iron silicate means FeSiO3 which is called slag. Now question 6.10. What is meant by the term chromatography? Chromatography is a collective term used for a family of laboratory techniques for the separation of mixture. The term is derived from Greek words chroma, meaning is color, and graphene, meaning to write. Chromatographic techniques are based on the principle that different components are absorbed differently on an absorbent. There are several chromatographic techniques such as paper chromatography, column chromatography, and gas chromatography etc. Question 6.11. Right criterion is followed for the selection of the stationary phase in chromatography, and the answer is the stationary phase is selected in such a way that a component of the sample have different solubility in the phase. Hence, different components have different rates of movement through the stationary phase, and as a result can be separated from each other. Now, question number 6.12. Describe a method for refining nickel. Nickel is refined by Mond's process. In this process, nickel is heated in the presence of carbon monoxide to form nickel tetracarbonyl, which is a volatile complex. Then the obtained nickel tetracarbonyl is decomposed by subjecting it to a higher temperature, means 450 to 470 Kelvin, to obtain pure nickel metal. Question number 6.13. How can you separate alumina from silica in bauxite ore associated with silica? To separate alumina from silica in bauxite ore associated with silica, first the powdered ore is digested with a concentrated NOH solution at 473 to 523 Kelvin and at 35 to 36 bar pressure. This results in the leaching out of alumina Al2O3 as a sodium aluminate and silica SiO2 as sodium silicate, leaving the impurities behind. After then, CO2 gas is passed through the resulting solution to neutralize the aluminate in the solution, which results in the precipitation of hydrated alumina. To induce precipitation, the solution is seeded with freshly prepared samples of hydrated alumina. During this process, sodium silicate remains in the solution. The obtained hydrated alumina is filtered, then dried and heated to get back pure alumina. Now, question 6.14. Differentiate between roasting and calcination, giving examples. Roasting is the process of converting sulfide ores to oxide by heating the ores in a regular supply of air at a temperature below the melting point of the metal. For example, sulfide ores of zinc, Zn, Pb and Cu are converted to their respective oxide by this process. On the other hand, calcination is the process of converting hydroxide and carbonate ores to oxide by heating the ores either in the absence of in a limited supply of air at a temperature below the melting point of the metal. This process causes the escaping of volatile matter leaving behind the metal oxide. For example, hydroxide of Fe, carbonates of Zn, calcium, magnesium are converted to their respective oxide by this process. Now, question 6.15. How is cast iron different from pig iron? The iron obtained from blast furnaces is known as pig iron. It contains around 4% carbon and many impurities such as S, P, Si, Mn in smaller amounts. And cast iron is obtained by melting pig iron and coke using a hot air blast. It contains a lower amount of carbon, 3% of carbon, than pig iron. Unlike pig iron, cast iron is extremely hard and brittle. Question 6.16. Differentiate between minerals and ores. Minerals are naturally occurring chemical substances containing metals. They are found in the Earth's crust and are obtained by mining. And ores are rocks and minerals valuable to be used as a source of metal. For example, there are many minerals containing zinc, but zinc cannot be extracted profitably from all these minerals. Zinc can be obtained from zinc blende Zn, calamine ZnCO3, zincite ZnO, etc. These minerals are called ores of zinc.